In this video, we are going to talk about solving linear systems of equations using substitution. As always, you are going to watch, listen, and take notes on your guided notes half sheet. So first of all, the substitution method is used to solve systems of linear equations by solving an equation for one variable and then substituting the resulting expression for that variable into the other equation. Now that sounds complicated and the steps seem a little complicated, but in the examples you'll see it's actually just a direct use of substitution where you remove something and replace it with something it's equal to. So step one is to solve one of the equations for one of the variables. So you're going to isolate either the x or the y. Step two is to substitute that expression into the other equation and solve for the other variable. Step three is to take your answer and plug it back into one of the equations, solve for the second variable. And then, as always, plug your answer in to check your work. Pause here to give yourself enough time to write these down. I'm going to move forward and look at two examples. So starting with example 1, we want to solve this system of equations. And remember, a system of equations just means that you have more than one equation and you're using the same variables. When we say we want to solve, what we are looking for is the point that makes both equations true. Okay. Now we could graph these, but we don't want that to be our only method for several reasons. So substitution is what we're going to use here. Step one is to isolate one of your variables. Notice that that is already done in this first equation. Typically, we will use substitution when that first step is already done. Now, I'm going to take what y is equal to. I'm going to go into the other equation, take out the y, and plug in the 3x plus 1. I can do this because of that equals right there. Y equals 3x plus 1, so I can remove the y, plug in 3x plus 1. I will typically do this with parentheses in case there's any multiplication that I need to do. So I want to be very clear about where this is coming from. This 4x stays a 4x. This 8 stays an 8. This y is replaced with the 3x plus 1 because they are equal. Now, notice what I have is an equation with just x. I know how to solve that. So the parentheses here weren't necessary. It's okay to have them, but they weren't necessary. Sometimes they will be necessary. I'm going to combine my like terms since they're on the same side. Subtracting 1 and dividing by 7. So what we have just done is determined the x-coordinate, which is 1, of our solution to this system of equations. Now our third step is to take what we got here, go back into one of the equations, plug it in to solve for y. I'm going to use the first equation because it's already solved for y. I could just as easily use the second one if I wanted to. So I have y equals 3x plus 1. That's my original equation. I'm going to replace the x with the 1. Do my arithmetic. And I get y equals 4. So my solution there, x is 1, y is 4. Now we can do a quick check. I'm going to do it over here. Don't write it over there on your paper because you can't erase like I can. If I do y equals 3x plus 1 and plug in 1 for x and 4 for y, I get a true statement. Hopefully you can see that without much work. And if I do 4x plus y equals 8, and I plug in 1 for x and 4 for y, I also get a true statement. So 1 comma 4 is the solution for this system of equations. Let's take a look at our second example. In our second example, we have negative 2x plus 3y equals 4 and x equals 2y minus 6. Notice this time our second equation already has that first step done. It is solved for x. It doesn't matter which one you substitute in. You're going to look for the one that is isolated by itself. And that's the one you're going to use for step 1. Now in step 2, I'm going to go into the first equation. I'm going to remove the x, and I'm going to plug in 2y minus 6. Everything else is going to stay the same. I'm just substituting 2y minus 6 in for the x, and it's legal because they are equal. Notice this time the parentheses were important because I need to distribute that negative 2. So I'm into step 3 where I'm solving the equation. Notice I only have y's now, so I can just solve like normal. I do need to distribute though. So I'm going to go negative 4y plus 12 plus 3y equals 4. I'm going to combine my like terms because they're on the same side. Subtracting 12. Here signs are different, so I subtract and keep the sign of the larger. And then dividing by negative 1, I get y equals 8. So again, when I'm looking to solve this system of equations, I'm looking for the point that makes both equations true. I've just found that the y-coordinate of that is 8. Now, to find the x, again, I can use either equation, but this second equation is already solved for x, so it's going to be the one that's easy to use. I'm going to plug 8 in for y. And then I'm going to do my arithmetic. So 16 minus 6, which is 10. So the x-coordinate is 10, and the y-coordinate is 8. This is how you'll write your answer as a point. Or you can say x equals 10, y equals 8. Now we can do a quick check. If I do negative 2x plus 3y equals 4, and I plug 10 in for x and 8 in for y, I get negative 20 plus 24 is 4, which is a true statement. And if I do x equals 2y minus 6, and I plug 10 in for x and 8 in for y, I also get a true statement. So to review, when you solve a system of equations using substitution, you're first going to isolate one of the equations for one of the variables. Normally that's going to be done for you. So you're looking for either x equals or y equals, one or the other. Then you're going to take that expression and substitute it into the other equation. That's going to give you an equation with only one variable. You can solve that. Once you have that answer, you're going to plug it back in, usually to the one where the variable was isolated, solve for your second variable, and then do a quick check to make sure you didn't make any careless errors.